Welcome. Today, we are diving into the fascinating world of infinity. We'll explore the concept of infinity, discuss the different sizes of infinity, and understand why some infinities are considered larger than others. Get ready to have your mind expanded as we unravel this mathematical mystery. Not all infinities are created equal. Some are infinitely larger than others. Let's begin. So, what exactly is infinity? Infinity is not a number. Rather, it is a concept that represents something without any bound or end. Think of it as something that goes on forever. It represents an unbounded quantity, a never-ending process, or a limitless size. We use the infinity symbol to represent this concept. Let's explore our first type of infinity, which is countable infinity. This type of infinity is denoted by Aleph null. A set is countably infinite if its elements can be put into one-to-one correspondence with natural numbers. Natural numbers like 1, 2, 3, 4, 5, 6, and so on are examples of countably infinite sets. Even numbers such as 2, 4, 6, 8, 10, 12, and so on can be mapped to natural numbers, making them countably infinite as well. Now let's look at Cantor's diagonal argument. This is a method used to prove that real numbers are uncountable. The argument goes like this. Assume that all real numbers between 0 and 1 can be listed. Construct a new number that differs from each listed number in its nth decimal place. For instance, if we have a list of real numbers R1, R2, R3, R4, and so on, we can create a new number by changing the nth digit of each number in the list. This new number will not be in the original list, which means the real numbers are uncountable. Now let's discuss uncountable infinity, which is larger than countable infinity. Sets that cannot be put into one-to-one correspondence with natural numbers are uncountable. The cardinality of the set of real numbers is called the continuum, denoted by the letter C. Real numbers, including all numbers on the number line between any 2 points, are an example of uncountable infinity. Power set of natural numbers is also uncountable. This is denoted by 2 to the power of n equals p of n. Let us compare the infinities we've discussed so far. Countable infinity, represented by Aleph null, includes natural numbers, integers, and rational numbers. This is considered a smaller infinity. On the other hand, uncountable infinity, represented by the letter C, includes real numbers, power sets, and the continuum. This is a larger infinity. Therefore, Aleph null is less than C. Believe it or not, the tower never ends. There is an infinite hierarchy of infinities. We use Aleph numbers to represent these levels. Aleph null represents countable infinity. Aleph 1 is the next cardinal number, followed by Aleph 2, and so on. Taking the power set of any infinite set always creates a larger infinity. This means there is no largest infinity because for any infinite set, its power set is strictly larger. Let's recap the key takeaways from our journey into infinity. First, infinity is not a number, but a mathematical concept representing unbounded quantity. Second, countable infinities can be mapped to natural numbers, as represented by Aleph null. Third, uncountable infinities are strictly larger than countable ones, with the continuum being greater than Aleph null. Finally, there exists an infinite hierarchy of infinities with no largest infinity. Some infinities are bigger than other infinities. This is a mathematical truth that revolutionized our understanding. Thank you for joining us on this mind-expanding adventure. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.